So we're gonna solve a problem for UVL today. UVL load. So you can see that I've already drawn the figure because I needed to draw it with the help of this scale. Without this scale, it looks very cluttered. So sometimes you wanna look clean. So I did it with the help of this scale. So first of all, the aim and objective of this problem is to draw the BMD on SFT. But before that, to find out the SFT and BMD, we need to find out the reaction. VV and VA. So let's get started. So first of all, we'll start with f of x equals to 0. HA is going to be 0. Summation f of y equals to 0. So from here, VA minus, for this law, area half into W into L plus VV equals to 0. So from here, VA plus VB equals to W L by 2. Equation 1. Now, for the moment, MA equal to 0. VA into 0. Yeah, VA into 0 plus half into base into height, and it is acting at the length of 2L by 3. 2L by 3 minus VB into L equals to 0. This 2 and this 2 get cancelled. This L and this L. So we are left with WL by 3. VB equals to, now we'll substitute this value to equation 1. Therefore, our VA becomes WL by 2 minus WL by 3. When this goes here, it becomes a minus. I hope you know all about this basics. I'm so sorry. Okay, now from here, it's going to be a 6. 3WL minus 2WL equals to WL by 6. So we have found out the value of VA and VB. VB is my WL by 3. VA is my WL by 6. It's not negative, it's positive. WL by 6. After that, we'll proceed for shear force diagram. Shear force diagram calculation. So for this, we will get upward force as positive and downward force as negative. So as if shear force at A here, this load is acting upward. So it's going to be WL by 6. WL by 6 kilonewton. Now, as if at A to B, from here to here, it's going to be WL by 6 for, and for this load, UDL, it's half into base into height, half into, yeah, and after that, from here, we need to solve it. It's going to be WL by 6 minus WL by 2. So it's going to be 6 to WL minus WL equals to 3. Okay, you do not have to cut it here. You can just keep it here as it is like that. And 2L W minus WL is going to be my WL. I'm so sorry, I made a mistake here. When you take the SN, you can see that it's going to be 3, and here 3 into 2 is going to be my 6. So here it's going to be 3WL minus WL. 1 into 6, 6 1 is 6. So from here it's going to be 2WL divided by 6. 3. So from here, as if at A to B is going to be my WL by 3 kilonewton. Okay, now we will find out the bending moment at section x distance from here. Now we are interested to find the value of this. So as if at C is going to be my, for L meter, we know that it's W kilonewton per meter. Similarly, for 1 meter, it becomes W by L kilonewton per meter. And for X meter, it is going to be my slope intensity is WL by X kilonewton per meter. Okay, so now our X length, we'll consider this as if at C is, first we have VA is WL by 6. After WL by 6, it's going to be my minus half into base into height. It's like X into W by L into X meter. It's going to be a 0. So from here, WL by 6 minus WX squared by L. WL squared by 2L equal to L by 6. It's going to be X squared by 2L. And after that, we multiply with 2X in order to get cancelled out. L by 6 equals to X squared by 2L. So by 2L, 2L cancel. 3. So from here, it's left with 2L by 3. Yeah, 2L by 3 and X squared equals to X equals to L by root 3, or X equal to L divided by root 3. Now the value of X is my L by root 3, and this is very important for the objective. Sometimes it asks shear force at the distance, where shear force is equals to 0 at the distance of how much meter. So it's simply going to be my L by root 3. Now it's done. I will draw for shear force diagram. Okay, first shear force at A is WL by 6. WL by 6. Okay, WL by 6 and shear force at B is W kilonewton, W by 3 kilonewton per meter, but it's in a negative, so it will go to downward, WL minus 3 on. So it will look something like this. I'll just draw till here, and from here to here it's 0. I cannot explain properly, but hopefully someday I will be. So now it's our, you can see that here the theta is 0. Now we solve for bending moment diagram calculation for BMD calculation. BMD at A is equals to load in the perpendicular distance is going to be minus 0, and again BM at B is equals to WL by 6 into L minus, this is for the WL by 6 into total length, minus for the load half into W into L into L by 3. From the base it's L by 3 equals to 0. It's all going to cancel out. You can see that W from this W, L from 6, 3 to the 6 is going to be a 0. So bending moment at C here, यहाँ पे bending moment at C. Now we'll calculate the bending moment at C. It's VA into X minus half into X into W, L into X by 3 from the base. So now you need to, in X का जगह में you need to substitute this L by root 3 simply. So BA का, what is the value BA? WL by 6 into L by root 3. It's getting difficult to write, minus 1 by 2 into L by root 3. L by root 3 into W by L to L by root 3 into L by root 3. L by root 3. 1 by 3. So after solving this, you will get WL squared by 9 under root 3. This is the bending moment at C. So we'll draw the diagram now. BMD. BM at A is equals to 0. BM at, it is what? WL squared by 9 under root. Point of contraplatzer. B. It's over now. When there are some points you need to remember, like for this, W by L into X kilonewton meter. So from here it's going to be X by 3. This will length is L by root 3, and you can write down some points by loading intensity. We can check for the slope of SFT diagram, and I have a tricky by the SF magnitude. We can check the bending moment SF magnitude. We can check the slope of BMD. Here you can see that theta A is not equals to 0, dm by dx is not equals to 0, so Vs is also not equals to 0. Now आप इसको ये से मिला के देख सकते हैं ना, यहाँ पे आपका 0 नहीं है, शेयर फोर्स WL by 6 है, तो ये आपका मैच कर रहा है. तो उसी तरह यहाँ पे आप जब टेंजेंट डालेगा तो यहाँ से आपका क्या हो जाएगा, थीटा C is equals to 0, dm by dx equal to 0, so Vc is equals to 0. So आप देख सकते हैं कि यहाँ पे आपका शेयर फोर्स 0 है. सो इसी तरह और यहाँ पे भी सिमिलरली इसका जैसा ही आप देख सकते हैं कि थीटा B is not equals to 0, dm by dx is not equals to 0, b is not equals to b. इसका मतलब शेयर फोर्स है, इसका मतलब है बेंडिंग मोमेंट रिस्पेक्ट टू x. यहाँ पे देख सकते हैं कि इट्स नॉट इक्वल टू 0. सो ये मैच कर रहा है. हम अच्छे से आई कैन नॉट एक्सप्लेन प्रॉपरली, सो यू कैन सी इट फ्रॉम हियर व्हाट इट मीन. I hope you get it. So yeah, that's all for today. Thank you.